Okay, so today's lesson, I'm going to start out and do the opener as a separate video lesson, and then we'll get into one of my favorite lessons as far as the calculus is concerned, and we'll take it from there. So here's the opener. If I let f of t equal t squared minus 3t, and then I'm going to have my area function, capital A of x, to equal the integral from 0 to x of f of t dt. Now because my area function is using x, I need my integrand function to use a different variable. Hence, that's why I'm using t. Alright, so I'd like you to find a of 3, a of 0, a of 9 halves. So, what does that mean? So we want to find, for a of 3, that simply means the integral from 0 to 3 of this function, f of t. So that would be all the area between 0 and 3, between the curve and the x-axis. Now, from what we know and what we understand about integrals, we know that should be a negative amount. And since that's a shape that we don't know how to actually calculate the area from geometry, we're just going to use our calculators and use the integral function on the calculator to come up with that answer. Alright, the next one is going to be a of 0. And for a of 0, that's the integral from 0 to 0. But wait a minute, that's no area at all, so we know that answer already is just going to be 0. And then for the last one, a of 9 halves, or 4.5, that'll be the area from 0 to 4.5 of this function. And in terms of our picture, that means we're going to go to about here. So for part of the picture, we're going to get area between the curve and the x-axis from above, and then the 0 to 3 part is going to be this much. So we're going to get a negative amount for the first section, and then a positive amount for the second section. And so we'll see what happens. Now, I've already punched this in on the calculator, and I've taken some screenshots, and it turns out that for the first part, the integral from 0 to 3, that wound up being negative 4.5. The second one, a of 0, we get 0 as I've already mentioned. And for the third one, it turns out that that area underneath the x-axis, between the curve and the x-axis, which we know is negative 4.5, this amount here, and then between 3 and 4.5, that area will end up being a positive 4.5, so together it will end up being 0. So in effect they canceled each other out, even though those aren't the same shapes. So that's kind of interesting that at 4.5 the integral will end up being 0. So what I'm curious about is, what if we had done this for a whole bunch of values? So let's take our function, which was t squared minus 3t, and let me write that down. And let's figure out, for a whole bunch of x values, let's find the area. So let me make a big table here. And actually I should say, yeah, let's say x, a of x. And remember, a of x was defined as the integral from 0 to x of f of t dt. So let's say x is, let's do negative 4, and then negative 3, negative 2, negative 1, 0, 1, 2, 3, and 4. Let's just try all those values, from negative 4 to 4. And now we want to calculate the area. Now we already know the answer for 3 was negative 4.5. And actually, I think I might want to go a few more. So let's keep this going. Let's do 5 and 6. Okay. We also know the answer for 0. That was 0. And let's figure out the rest using our calculator. So we're going to go from negative 4 all the way to positive 6. So in y equal, let's put our function in there. Now I have to use an x there, x squared minus 3x. Okay, and now what I'm going to do is from the home screen, I'm going to go into the math menu and go down to number 9. And I'm doing from 0 to, the first one will be negative 4 of the function that I just put in y1 with respect to x. Okay. And we get negative 45.3 repeating. Negative 45.3 repeating. Now here's what I'm going to do. I'm going to go into Stat, Edit, and I'm going to create a table of these values. And I can put these in right now. Okay, so there's all the x values. And now I'm just going to press second enter, and I'm going to back up and change the upper limit of my integral. This time we'll do negative 3. We get negative 22.5. We go into Stat, Edit, go down there and put the answer into that spot. And I'm just going to keep going now. Second enter, make that negative 2, get my answer, Stat, Edit, put the answer in, and away we go. Keep collecting these. This is going to take a minute or two here. Negative 1. I got negative 1.83 repeating. Let's put that answer in there for negative 1. Now we already know for 0 it's 0, so I don't have to punch that in. Okay, let's go back now. Let's do 1, positive 1. There we go. Stat edit, we'll put that in. Oops. I messed that one up. Let's see if I lost it or I have to put that back. And no, it's still there. Good. Okay, second answer. There we go. We have to do 2. And I would suggest going through and trying to do this yourself, just to be familiar with being able to do this sort of a thing. Now we have to do 3, but we know the answer for 3 was negative 4.5. Okay, now we'll go to 4. Negative 2 2/3. Okay, 2 more. Put in 5. Now we know this is going to be a positive amount because at 4.5 we wound up getting 0 again. So now we have more above the x-axis than below. And let's do the last one. That's 6. Probably wondering, why are we doing this? Why am I watching him do this? I have better things to do with my life. Not really. Alright, let's go down to the last one. Put the answer in there. There we go. So now we have this whole table of values. And I'm not going to write them on the screen. I mean, I could plug them all in on the screen, but I'm not going to do that. So let's... Oh. Here's what I could do, though. Go back to here. View. Screen capture. Got it. Alright, so there's all these values. Okay, so now what I'd like to do is, this looks, I wonder if we graph all these points, is there a function we could come up with which goes through all of these points? And if so, then we would actually have an area function. We wouldn't have to just keep doing individual values. We could just say, oh, what's a of 13? And we could plug 13 into this area function and get an answer. So the function is just like the function on the calculator that we use the integral for, except I wonder what it looks like. So in y equal we have that. So if I hit graph, this is the parabola that we're finding the area from 0 to whatever, between the graph and the x-axis. So now what I want to do is plot all the area values. So I'm going to go to stat plot. I'm going to turn that on. I'm going to have it as a scatter graph. My x numbers are in L1, and my y numbers I put in L2. I'll use the big mark, it'll be easier to see, and I'm going to hit graph. Now, look at those points. Let me go back to y equal for a minute, and let's change this to a different color. There we go. Had trouble making up my mind on that. Okay. So the green is our function. The blue represents the values from our area function. Now, that looks to me like it's increasing, then it levels up, then it decreases, then it levels off, then it increases again. That takes on a cubic shape, at least in my mind. So I'm going to try and fit a cubic graph to that. So I'm going to press stat, and I'm going to go over to calculate, and I'm going to do a number 6, cubic regression. My numbers are in L1 and L2. I can actually store the equation, so let's store that equation in y2, and then let's go ahead and calculate it. There it is. Now notice those c and d values. 7.6 e negative, that means 7.6 times 10 to the negative 13th power. That's almost 0. So I'm guessing that c and d are both 0. So it looks like a is 1/3, so y equals 1/3 x cubed, and b is negative 1.5, so it looks like negative 3/2. And then that's times x squared. Let me write that down over here, and then I'll come back to the calculator. So it looks like this area function wound up being 1/3 x cubed minus 3/2 x squared. That's interesting. Maybe only to me. Let's go back. So now when I go ahead, that's in y2, when I go ahead and graph, there it is. And that fits it perfectly. Goes through all those spots. Look at that area function. That's a cubic. Look at the original function. That's a quadratic. When you look at this, how do you get from the area function to the integrand? Do you see it? Alright, that's where I'm going to stop. Some of you may know where I'm going with this. Some of you may have seen this before. But now we're ready to talk about the fundamental theorem of calculus. And so that's going to be the main notes for today.